Hi, this is Mrs. Bone here, and today I'm bringing you a screencast on how to multiply, divide, and add and subtract numbers in scientific notation. And recall that scientific notation is an abbreviation for very large and very small numbers used in science. So let's get right to it. How do we multiply numbers in scientific notation? And if we take some number written in scientific notation, a times 10 to the b, and we multiply it by another number written in scientific notation, which is denoted here by c times 10 to the d, that's going to equal a times c times 10 to the b plus d. Simple, right? Easy. Yeah, no. Okay, so this looks complicated, but I'm going to break this down for you. When you see something like this in a math book or on a board, don't be afraid by it. Don't be put off. You can actually understand this. And let's put an actual, this just represents a number in scientific notation, like 4 times 10 to the third. This also represents another number in scientific notation. And this is equals how we're going to solve it. So let's look at what we do here. If we have 4 times 10 to the third times 2 times 10 to the fifth, well, what does that equal? Well, what did they do here? Where did this 4 times 2 come from? This a and this c. Well, they took these leading two numbers, and all they did was they multiplied them together. So 4 times 2, what does that equal? That equals 8. And they raise it to the 8th power. Well, how did they get this 8? Well, they took these exponents and they added them. And that's all you got to do when you're multiplying and dividing scientific notation. 4 times 2 times 10 to the 3 plus 5 is 8. All you do, multiply the leading numbers, add the exponents. And that's exactly what this says. You multiply the leading numbers, a and c. A times c, it's just a general form of the equation. And then you add the exponents, b plus d. So even though this thing looks really complicated, it's not really, right? So let's do a sample. Oh, this is the rule out. Multiply the leading numbers and add the exponents if you want to write that down. And let's do a couple sample problems. And we'll come back to that one in a second. 3 times 10 to the 8th times 6 times 10 to the first. And what was the rule? Well, we have to multiply these leading numbers. We're going to multiply. And we got to add the exponents. What is 3 times 6? 3 times 6 is, of course, 18 times 10 to what power? 8 plus 1. And some of you are probably doing this in your head. I'm just doing it out to keep it simple for you. But some of you probably just looked at it and said, okay, that's 18 times 10 to the 9th. And that is absolutely correct. Note that this isn't in scientific notation. It's in exponential notation. There are not two numbers to the left of this decimal point. Or there isn't one non-zero, there's two. This is actually, I would probably accept this if we're multiplying and dividing in scientific notation. But you could move this decimal over and essentially add 1 to this. Make this 1.8 times 10 to the 10th power. That's what that would come out to be. So, because this means you're going to add 9 zeros to it. If you move that over, you'd have to add 10 zeros. So, that would be how to put that in the scientific notation. If we're multiplying and dividing in physical science or chemistry, this will be acceptable. If you're in physics, this is what I want. Another one here. What do we do here? Well, you multiply the leading two numbers. And this is one you probably can't do in your head. And if I'm giving you a calculator free test, you won't have one like this. But you just multiply these two numbers and add the exponents. What's 10? 8 plus 1, it's 9 times 10 to the 9th. And all you're going to do is put 2.235 in your calculator times 6.453. And whatever that comes out to be, somewhere around 13 probably. I'm not even going to give you an answer for that. That's how easy scientific notation is, multiplying. Multiply the leading numbers. Add the exponents. You are done. And what about division? Or actually, let's go back to the other one. We saw this slide a few screencasts back, and this was Newton's law of universal gravitation. And I just want you to see how knowing how to multiply and divide in scientific notation can simplify something like this. If you wanted to do this longhand without scientific notation, these are the numbers you got to put in your calculator to calculate the force of gravity the sun exerts on the earth and vice versa. If you streamline it into scientific notation, it becomes much easier to put in your calculator. If you know rules for multiplying and dividing scientific notation, you should know that you're taking this number times this number times this number. You multiply the leading numbers, which is right here. And then you would just simply add all the exponents together, right? Add these three exponents together. And the same thing with the bottom. It's 1.496 times 10 to the 11 squared. It's this number times itself. 1.496 times 1.496 times 10 to the 11 plus 11. And maybe that's a little confusing for you right now, just learning this. But just realize that if you know how to multiply numbers in scientific notation, you can even streamline this problem a little bit further. This is how I would solve this. And as you go along in your sciences and become better at scientific notation and see it numerous times, you would hopefully be able to do this. And even in chemistry, when you're doing moles, please use scientific notation. Do yourself a favor. It makes it much, much easier. You do double the work if you're not doing scientific notation when you're doing moles. So let's look at division. How do we divide numbers in scientific notation? And again, hopefully this rule is not scary anymore. If you had some number, a times 10 to the b, and you were dividing it by some number, c times 10 to the d, what are we going to do in this case? Oh, they're going to take this leading number, and they're going to divide it by this one. Just dividing the leading numbers this time. And instead of adding the exponents, b and d, you're just going to subtract them. So let's use a concrete example. 6 times 10 to the third divided by 2 times 10 to the sixth. What do? Well, we take the leading numbers, and we divide them. 6 over 2 is going to be 3. What do we do with the exponents? We subtract them. 3 minus 6 is a negative 3. Final answer. 10 to the negative third. Yes, it is that easy. So we divide the leading numbers and subtract the exponents when we're dividing. And we'll do a couple sample problems here. 8 times 10 to the 8th divided by 4 times 10 to the first. What do? We take these leading numbers. We divide them. 8 divided by 4 times 10 to the, subtract the exponents. 8 minus 1. 8 over 4 is, of course, 2 times 10 to the 8 minus 1 is 7. And you could probably did this in your head much quicker than I did this. Some of you are probably ahead of me. How about this one? 3 divided by 6, right? We divide the leading numbers. And times 10 to the, subtract the exponents. 4 minus 7. 3 divided by 6 is 0.5 times 10 to the negative third. And this is a weird looking number. But if you wanted to put this in the scientific notation, you would go this way and make this a negative 4. 5 times 10 to the negative 4. This is a tricky one. It's really tricky to get a decimal with a negative sign into proper scientific notation. So my physics students, you will struggle with this one a little bit. But the rest of us, you could have left it like this. I don't expect my physical scientists to be able to convert this number into that. But generally, this number does equal that. But that's how we divide scientific notation. Sometimes we get a weird number like this. And you could put this number in your calculator if you wanted to, as long as you're not on my test. And it'll express this number in standard notation. It'll tell you that it's 0.0005. That's what 5 times 10 to the fourth is. Both of these numbers will be the same thing. Adding and subtracting scientific notation. The rule is you have to convert the numbers to the same power. And then you keep the exponent and you just add the numbers. So the idea is this number right here has to be the same as this one. So we have to convert one of these numbers. We have 4 times 10 to the first. And this problem is much easier in standard notation. 2 times 10 squared is just 200. And this is just 40. 200 plus 40 equals 240. We know that. But if you want to make these numbers the same power, and we assume there's a decimal here in front of the 2, and you could say 2 is the same thing as 20 times 10 to the first plus 4 times 10 to the first. And 2 times 10 to the second is the same as 20 times 10 to the first. When you're adding and subtracting in scientific notations, you have to make the exponents equal. Now it's just a matter of 20 plus 4, and you keep the exponents. 24 times 10 to the first. And that's actually 240, which is what we got up there. So the rule for, adding and subtracting in scientific notation, unless the numbers are really, really, really big or really, really small, then it's not as useful as the multiplying and dividing one. For this, it's just you're complicating it more than you need to be. Just say 200 plus 40. And for this one right here, we have 2.5 times 10 to the fourth, which we could also always make this. Or we have 2.5 times 10 to the fourth plus 4.4 times 10 to the third. We have to change these powers. You could change either one. You could move the decimal this way and make that a 4. Or what would be easier is to move this decimal over this way and say 2.5 is 25 times 10 to the third. You got to be comfortable with scientific notation to add and subtract in it, though. You got to be very comfortable with it. Otherwise, you might mix up what you're doing. 4.4 times 10 to the third. Now these powers are equal, so you can just add these numbers together and keep the power. 25 and 4.4 is going to be 29.4 times 10 to the third. When you're adding or subtracting, you don't change the power. Once you get the powers equal, you just keep it in your final answer. And you could, of course, convert this to strict scientific notation if you wanted to, but unless you're in physics, you don't have to. Alright, so you have an assignment here, and I summarized the rules for you. When you're multiplying, multiply the leading numbers, add the exponents. Dividing, divide the leading numbers, subtract the exponents. I forgot to change that when I copy and pasted it. And adding and subtracting, convert the same power, keep the exponent, add the leading numbers. So you have some sample problems here. 4 multiplication ones, right there. A couple subtraction addition ones and division ones. Try your best with these. These are oddly enough, adding and subtracting in scientific notation is the hardest, and multiplying and dividing is the easiest. Hopefully you at least understand the tricks for multiplying and dividing scientific notation. Some of these should be easy. You should be able to do this in your head. 9 over 3, 6 minus 4, hopefully. This is Mr. Phone. Hopefully you have a better understanding of performing arithmetic operations in scientific notation. I'm out.